We're going to start Chapter 5 on trigonometry today. Angles and their measures is the first section. This is a lot of definitions and getting us up to speed with some terminology. So first of all, trig is a branch of math that studies relationships between side lengths and angles of triangles. So specifically, we are going to look at some of the following things. In section 5.3, we look at right triangles and the relationship of the sides of right triangles. In section 5.2 and 5.4, we look at what we call the unit circle and find trig function values based on points on the xy axis. And in 5.5 and 5.6, we will look at the graphs of trig functions themselves. The other two sections that we will cover are 5.7, which covers inverse trig functions, and 6.4, which covers equations with trig functions. Now for some terminology. A line segment is a line that connects 2 points. A line continues to negative and positive infinity. An array is a combination of those two things that starts at a point and continues in infinity in one direction. An angle is formed by rotating a ray around its endpoint. The initial side of the angle is the starting point of the ray, and the terminal side of the angle is the final position of the ray. The vertex of the angle is the point about which the ray is rotated. If we look at angles on the xy axis, an angle is said to be in standard position if its initial side is on the positive x-axis, and the vertex is at the origin, or 0, 0. Angle measurement. So the measure of an angle is determined by the amount of rotation of the ray as it goes from the initial side of the angle to the terminal side. We often use Greek letters to stand for the measure of an angle, such as alpha, beta, and theta. One of the units that we use to measure angles is degrees, and an angle of measure 360 degrees makes a complete rotation from its initial side to its terminal side. An angle created by a counterclockwise rotation has positive measure greater than 0, and a clockwise rotation has a negative measure, as seen in the pictures. An angle in standard position with terminal side on the x or y axis is called a quadrantal angle. Those are angles with measure of 0 degrees, which is on the positive x-axis, 90 degrees on the positive y-axis, 180 degrees if the terminal side is on the negative x-axis, 270 degrees if the terminal side is on the negative y-axis, and we could also have an angle of 360 degrees if the terminal side is on the positive x-axis. We can give specific names to angles that have measurements related to the x and y axes. First of all, an acute angle has measure of less than 90 degrees. Its terminal side is in quadrant 1, as we can see in the picture here. A right angle has measure of exactly 90 degrees, and its terminal side is on the positive y-axis. An obtuse angle has measure between 90 degrees and 180 degrees, and the terminal side is in quadrant 2, like we see in this picture right here. A straight angle has measure of 180 degrees. The terminal side is on the negative x-axis. Now let's practice sketching the following angles on the xy axis. Pause and sketch the angles. So let's sketch 120 degrees. Our initial side is on the positive x-axis, and we want to rotate to 120 degrees. So remember that this is 90 degrees, 180 degrees is the negative x-axis. 120 is in between those. It's about 30 degrees, so it's exactly 30 degrees past 90. So we want to estimate that as we rotate this initial side about 30 degrees, or about a third of the way through quadrant 2. And that would get us to the terminal side for an angle that has measure of 120 degrees. For negative 45 degrees, we're going to go in the clockwise direction to get a negative measure. So here we have 0 degrees. If we measure this as a negative, this would be negative 90 degrees. So if we take initial side, positive x-axis, we're going to rotate it clockwise. 45 degrees is 90 degrees, so our terminal side is cutting that quadrant in half. So we have rotated in the clockwise direction, negative 45 degrees, and that gives us that angle of measure negative 45 degrees. 450 degrees is greater than 360, so this is going to be more than one complete rotation. So if we take our initial side as the positive x, we are going to rotate around one whole rotation. That gets us to 360, and now we want to go another 90 degrees. And our terminal side is the positive y-axis. We have some other definitions. Two acute angles are complementary if the sum of the measures of their angles are 90 degrees, and they are supplementary if the sum of their measures is 180 degrees. So let's practice that. Let's find an angle with measure theta that is complementary to an angle of 56 degrees. That means that 56 plus whatever the measure of that angle is equal to 90 degrees. So we're going to find the measure of theta is 90 degrees minus 56 degrees. So theta is 34 degrees. Now let's find theta so that it's supplementary to an angle of 73 degrees. We would take 73 degrees plus that angle measure theta, and that's equal to 180 degrees. To find what theta is, we take theta equals 180 minus 73, so we get angle measure of 107 degrees. Coterminal angles. If two angles have the same initial side and terminal side, they are called coterminal angles. For an example, if we take a 135 degree angle, this one here, it is coterminal with both 495 degrees and 855 degrees. Now to get to that 495, we would take that 135, and what we're doing is adding a complete rotation to that. So we're adding 360 degrees. So 135 plus 360 gets us to that 495. For 855, we are taking 135 and we are adding 2 full rotations. So 2 times 360 degrees, or 720, and that's what gets us to 855 degrees. Now let's find the coterminal angles for negative 60 degrees. And we're going to find one that's positive and one that's negative. So to find the one that's positive, which is 300 degrees, we are just simply adding a full counterclockwise rotation. So we are adding 360 degrees, and that gets us to that positive 300 degrees. Now to get the negative one, we're going to start with that negative 60 degrees, and we are going to go in the same direction as it was that we got negative 60 degrees. So we're going to go in that counterclockwise motion, so we are going to subtract 360 degrees. So negative 60 minus 360, we get the negative 420 degrees. Okay, here's some to practice with. Go ahead and pause and practice, and then start up again. So first of all, we have an angle of 30 degrees. Let's go ahead and put that on our XY axis. So there's our initial side. 30 degrees is going to be a third of the way up to 90 degrees. So Let's put that right there, call that 30 degrees. Now we want to find a positive angle that has that same terminal side. We start with that initial side on the positive x-axis. We're going to make one full rotation and then end at that same terminal side. So to get that red angle measure, we'll call that theta. It is 30 degrees plus one full rotation, 360. So that angle measure is 390. One angle that is coterminal with 30. So now let's find the negative angle that's coterminal with 30. So we're going to start at that same initial side. This time we're going to go in the negative direction and end up on that same terminal side. So to find that angle measure, we'll call that theta prime. We're going to take 30. Because we went in the opposite direction, we're going to subtract 360 degrees, and we get negative 330 degrees for the negative coterminal angle. Now let's find positive and negative coterminal angles for negative 150 degrees. So sketching negative 150 degrees, our initial side is on the positive x. We are going to go in the clockwise direction. We go to negative 90 and then another negative 60 degrees. So we're going to end up about right there. Right, so in the blue we've got negative 150 degrees. We want to find the positive coterminal angle. So we start at the same initial side, and this time we go in the counterclockwise direction. So let's call that angle theta. So theta, the positive coterminal angle, is our original angle, negative 150 degrees, plus 360. All right, so we get angle measure of 210 degrees. Now let's look at the negative angle that's coterminal. So we start at that same initial side, and we are going in the clockwise direction, and we're going to make one full rotation and then go all the way to that same terminal side. So to find that angle measure, we're going to go negative 150 minus 360. All right, so we get negative 510 degrees. Another way that we can measure angles is with radians. 360 degrees, one whole rotation is equal to 2 pi radian, where of course pi is that irrational number that's approximately equal to 3.14. To convert between radian and degree measure, we use that equality, 360 degrees equals 2 pi. If we divide both sides by 2, that gives us another equality of 180 degrees equals pi. A lot of times we want to do this conversion. So to convert an angle from degrees to radian, we are going to multiply by pi over 180 degrees. All right, because those are equal, that pi over 180 is just equal to 1. And if we want to go from radians to degrees, we flip that over. We get 180 over pi. Again, those are equal things, so that ratio is just equal to 1. So let's practice. Let's convert 60 degrees to radians. Because we are going from degrees to radians, we are going to multiply by pi over 180 degrees. So you notice that the degrees are in the top and the bottom, so those are going to cancel each other out. We're going to get rid of degrees, we're going to be left with pi. So before we do this multiplication, we can do a little bit of simplifying. So 60 goes into itself once, and 60 goes into 180 3 times, so we are left with pi over 3. All right, so 60 degrees is pi over 3. All right, that's one equivalent degrees to radian that we want to remember. 60 degrees is pi over 3. Now let's look at 225 degrees. So 225 Okay, we're converting to radians, so we want to multiply that by pi over 180, right? We want those degrees to cancel out. So since we've got degrees in this numerator, 225, we want degrees in the denominator so they cancel out. So you can think of those canceling out. That goes away, that goes away. And we, again, can do some canceling of the 180 and the 225. This time 45 goes into both of those. So 45 goes into 180 4 times. 45 goes into 225 5 times. So what we end up with is 5 times pi, so 5 pi, over 1 times 4, or 4. Now let's go the other direction and convert 5 pi over 6 to degrees. Okay, so this time we want the pi to cancel out. So what we're going to multiply by is 180 in the numerator over pi. So there you can see that the pi's are going to cancel out. We're going to be left with just degrees. So let's do some canceling. 6 goes into 6 one time. 6 goes into 180 30 times. So our result is 5 times 30, which is 150 degrees, over, we're just left with 1 times 1 in the denominator, so we get 150 degrees. All right, now let's look at negative 3 pi over 2. Okay, we're multiplying to cancel out that pi. So we're going to multiply by 180 over pi. So we can see that the pi's will cancel. And 2 goes into 2 once. 2 goes into 180 90 times. The degree stays on there. And so in the numerator, we get negative 3 times 90 degrees. So that's a negative 270 degrees. In the denominators, we have 1 times 1, so we end up with just 270 degrees. Now let's look at those quadrantal angles in terms of radians. So this first one, we've got t equals, or angle measure equal to pi over 2 radians. That is comparable to the quadrantal angle of 90 degrees, right, where we're rotating to the positive y-axis. And then we have angle measure of pi radians. That is the same as 180 degrees, where we rotate to the negative x-axis. The angle measure 3 pi over 2 is the same as 270 degrees, where we rotate to the negative y-axis. And then finally, 2 pi is the same as 360 degrees, where we do 1 full rotation, starting at the positive x and ending at the positive x.